Welcome back to today's session. In the previous session, we discussed the procedure of stepping stone method. Today, we were supposed to solve one problem on stepping stone method. So, we'll be solving it. So, the problem that I've considered is bit lengthy, or it takes around three iterations. But I've taken this problem because uh, you will be able to look into all possibilities that you encounter in stepping stone method. I've considered problems such that all the required cases that you need to learn in stepping stone method has been dealt with in this problem. So the problem is we have three origins and four destinations. The cost matrix given is 21, 16, 25, 13, 17, 18, 14, 23, 32, 27, 18, 41. The supplies are 11, 13, 19. Demands are 6, 10, 12, 15. So the problem says obtain the IBFS of the transportation problem using LCM and optimize it using stepping stone method. So because the decision variable is a cost matrix, it is a minimization case. And next thing that we are supposed to check is if the supply and the demand would match, so that we'll get to know whether it is a balanced problem or not. So when I add up the supplies and the demands, I get 43. So since summation AI is equal to summation Bj is equal to 43, the problem is a balanced transportation problem. So what are we supposed to do next? Compute the IBFS using least cost method. So when I apply least cost method in the cost matrix, which is the least cost, 13 is the least cost. So here I am supposed to make an allocation. How much? Supply is 11, demand is 15. So I can satisfy 11. So I get an allocation at 1, 4 with 11 units. So the first row is gone. Now the remaining matrix is 17, 18, 14, 23, 32, 27, 18, 41. So the next least cost is obviously 14. So I'm supposed to make an allocation at 14. How much? Supply is 13, demand is 12. So I can satisfy 12. So I make an allocation of 12 at 2, 3. At 2, 3, 12 units. So the first row is gone. The third column is gone. Now remaining cost matrix is 17, 18, 23, 32, 27, 41. Which is the minimum? 17. So I'm supposed to make an allocation here. How many units? Supply is 1, demand is 6. So I can satisfy only 1. So I get an allocation of 1 unit at 2, 1. 2, 1, 1 unit. So this column is gone. First row gone. Second row also gone. Now the remaining cost matrix is 32, 27, 41. So which is the least cost? 27. So I'm supposed to make an allocation here. How much? Demand is 10, supply is 19. So I can satisfy 10 units. So make an allocation of 10 units at 3, 2. 3, 2, 10 units. First row, second row, second column, third column. All this is gone. I'm left out with only two cost elements, 32 and 41. Minimum amongst them is 32. So make an allocation here. How much? Demand is 5, supply is 9. So I can satisfy 5. So at 3, 1, 5 units. So first column, second column, third column, all the 3 columns are gone. First row is gone, second row is also gone. So I'm left out with a single cost unit. So whenever there is a single cost unit left out, so I am supposed to have supply and demand matching each other. So in that case, what am I supposed to do? Match the supply and demand, make the allocation. Supply is 4, demand is 4, so satisfy 4, so that the last row and the last column both will be gone. So I get an allocation of 4 units at 3, 4. So compute the TTC for this. So it is 11 into 13 plus 1 into 17 plus 12 into 14 plus 5 into 32 plus 10 into 27 plus 4 into 41. So I get 143 plus 17 plus 168 plus 160 plus 270 plus 164. So when you add up all this, you get a 912. So the IBFS TTC says the total transportation cost is 922. So now we are supposed to optimize the solution. For this, first step is check whether degeneracy case exists. 3 plus 4, 3 is the number of rows, 4 is the number of columns. 3 plus 4 minus 1. 3 plus 4 is 7, 7 minus 1 is 6. Do I have 6 allocations? 1, 2, 3, 4, 5 and 6. So 6 allocations are there. Fine. So non-degeneracy case, go about optimizing. So the stepping stone method says, identify a cell which is non-occupied. The first non-occupied cell is D1O1, right? That is what I have written here. Cell is O1D1. So for this, find the closed loop. So the closed loop will be O1D1, O1D4, O3D4, O3D1. Okay. Once you have got this closed loop, write it down. So O1D1, O1D4, O3D4 and O3D1. So this closed loop is written. After writing the closed loop, the net changes has to be evaluated, or the net cost change has to be computed. So how do we compute this? So all the unit costs in the closed loop has to be considered by putting alternative signs. So wherever I had considered the beginning point of the closed loop, there I should get a plus, then a minus, then a plus, and then a minus. Okay. So wherever I have got a plus, I'm supposed to add it. Wherever I've got a minus, I'm supposed to subtract it. So I get a plus 21, minus 13, plus 41, minus 32. So 21 plus 41 is 62. 62 minus 13 minus 32 is a plus 17. So when I apply this closed loop, I got an increase in the net cost change, right? That has been mentioned here. It is an increase in cost. So now I will take the next unoccupied cell, O1D2, as the reference, right? O1D2 is considered as the reference. For this, once again, I'll have to construct the closed loop. O1D2 is the reference, then O1D4, O3D4, then O3D2. So that has been mentioned here. O1D2, O1D4, O3D4 and O3D2 forms the closed loop. So find the net evaluation or net cost change here. So it will be plus 16, minus 13, plus 41 and minus 27. So which will once again lead to a plus 17, an increase in the cost. Next, identify the next unoccupied cell, O1D3, as the reference. O1D3 becomes the reference. For this, I am supposed to find out the closed loop, O1D3, O1D4, O3D4, From there, I come to O3D1, O2D1, O2D3, and back to the original position. Starting from the original position, plus, minus, plus, minus, plus, and a minus. So the loop that I have formed is starting from O1D3, O1D3 to O1D4, O1D4 to O3D4, O3D4 to O3D1, O3D1 to O2D1, O2D1 to O2D3. So once I have formed the closed loop, so we are supposed to calculate the net change cost. Net change cost will be plus 25, minus 13, plus 41, minus 32, plus 17, and a minus 14. So when I add up all the plus values and subtract the minus values, I get a plus 24. So this is leading to a increase in the net cost change by 24 units. So next unoccupied cell is O2D2. So I'm supposed to consider O2D2 as reference. So when I consider O2D2 as reference, from O2D2, I go to O3D2, O3D2 to O3D1, O3D1 to O2D1. Okay, this will form a closed loop. So I mentioned that in the closed loop here, O2D2, O3D2, O3D1, and O2D1. So now, starting from O2D2, plus, then a minus, then a plus here, and a minus here. So the net cost change will be plus 18, minus 27, plus 32, minus 17. So this will also give us a plus 6. This also causes an increase in the net cost change. So once I've got an increase in the net cost change, consider the next point of reference. It will be O2D4. O2D4 will be the point of reference. So for this, identify the closed loop. O2D4, then O3D4, then O3D1, then O2D1. Okay? So mention that in the closed loop, O2D4, O3D4, O3D1, O2D1. Okay? Starting from O2D4, plus sign, a minus sign here, a plus sign here, and a minus sign here. Net cost change will be plus 23, minus 41, plus 32, minus 17. So when I evaluate it, I get a minus 3. So there is a decrease. There is a possible decrease in the total transportation cost that is available. I can still decrease the cost. So I will mention it as decrease. So next point of reference will be O3D3. O3D3 will be the point of reference. Construct a closed loop O3D3. From there I go to O3D1, O3D1 to O2D1, O2D1 to O2D3, and back to O3D3. So mention that in the closed loop, O3D3, O3D1, O2D1, O2D3. Starting from O3D3, a plus sign here, a minus sign here, a plus sign, and a minus sign at O2D3. Fine. So the net cost change will be plus 18, minus 32, plus 17, minus 14. So when I evaluate it, I get a minus 11. So which is a possible decrease in the transportation cost. So I have mentioned it. See, wherever I have increase, I am least interested in it. That is why I have shaded it in red. This is not of any concern for me because I am not interested in maximizing the cost. I am interested in minimizing the cost. I want to decrease the cost. Therefore, only these two have to be considered. Out of these two, compare which is the most negative. Most negative is minus 11. So consider that loop. So identify that particular loop. The loop is O3D3, O3D1, O2D1 and O2D3. So this is the loop which is causing maximum decrease. So in this, wherever you have minus, like you calculated theta earlier, wherever you have minus, out of those, identify the minimum allocation. So we have 5 and 12. Out of this, 5 is minimum. So that will be the shift that we perform. So this minus, because I have a minus here, 5 minus 5 will give me a 0 here. So because I have a plus, 1 plus 5 gives me a 6 here, a 6 here, a 0 here. Then here I have a minus, 12 minus 5, I get a 7. Here I had a 0, 0 plus 5 gives me a 5. So the new transportation table will be 6 here, 7 here and a 5 here. And this has become a 0. So for this, let me calculate the transportation cost and check whether there is an improvement. So the TTC is 11 into 13 plus 6 into 17 plus 7 into 14 plus 5 into 18 plus 10 into 27 plus 4 into 41. So I get a total transportation cost of 867. Earlier I had 992. So there is an improvement. There is a good improvement in the total transportation cost. But is it an optimal solution? No. It is not an optimal solution because all the net cost change were not positive or zero. Therefore, this is the improved solution but may not be the optimal solution. So we go ahead once again to form the loops, perform stepping stones and identifying whether we have arrived at an optimal solution or not. So for this new solution that I've got, how many allocations I have? 1, 2, 3, 4, 5, 6. 6 allocations. So non-degeneracy case, go about starting off with stepping stone. First unallocated cell is O1D1. So find a closed path for this. O1D1 to O1D4, O1D4 to O3D4, O3D4 to O3D3, then O2D3, then O2D1, back to O1D1. So the loop that I've identified is O1D1, O1D4, O3D4, O3D3, O2D3, and O2D1. So now, as usual, put plus in the beginning point, alternating signs. So I get a plus here, minus, plus, minus, plus, minus. Find out the net cost change, plus 21, minus 13, plus 41, minus 18, plus 14, minus 17, which will sum up to plus 28, which is an increase in cost. Go to the next unoccupied cell, O1D2. So this is the unoccupied cell. Form the loop. O1D2 to O1D4, then O3D4, then O3D4, O3D2. So the closed loop that I formed is O1D2, O1D4, O3D4, O3D2. So put alternating signs, plus, minus, plus, minus. So the net cost change will be plus 16, minus 13, plus 41, minus 27. So when you evaluate it, you get a plus 17, which is an increase in cost. Go to the next reference point, O1 D3. So identify the loop O1 D3, O1 D4, O3 D4, O3 D3, right? Mention the closed loop O1 D3, O1 D4, O3 D4, O3 D3. Put the alternating signs plus, minus, plus, minus. So the net cost change will be plus 25, minus 13, plus 41, minus 18, which will evaluate to plus 35, which is an increase in cost. So next unoccupied cell is O2D2. So for O2D2, identify the closed loop O2D2 to O2D3, O3D3, then O3D2. So mention that here O2D2, O2D3, O3D3, O3D2. Put the alternating signs plus, minus, plus, minus. So the net cost change will be plus 18, minus 14, plus 18, minus 27, which will be a minus 5. So there is a possibility of decrease. So whatever I had got was not an optimal solution. So go to the next unoccupied cell, which is O2D4. From O2D4, identify the loop O2D4, O3D4, O3D3, O2D3. Mention it O2D4, O3D4, O3D3, O2D3. Put alternating signs plus 23, minus 41, plus 18, minus 14. So when you evaluate it, I get a minus 14. So there is a further possible of improvement in the solution. Minus 14, which is a decrease in cost. Now, the next unoccupied cell, O3D1. For O3D1, form the loop O3D1, O2D1, O2D3, O3D3. Mention it O3D1, O2D1, O2D3, O3D3. Right? For this, put alternating signs plus, minus, plus, and a minus. So the net cost change will be plus 32, minus 17, plus 14, and a minus 18. When you evaluate it, you get a plus 9, which is an increase in cost. So wherever I have increase, I am not interested in it. Wherever I have a decrease, out of that, which is the maximum decrease, I check. The most negative net cost change is minus 14. So the loop is O2D4, O2D4, then O3D4, O3D3, and O2D3. So this is the possible loop which will increase or decrease my cost. So out of that, identify the theta value. So minus here and a minus here. So I have an allocation of 4 here and a 7 here. Minimum out of the allocations is 4. So 4 has to be moved. So 4 minus 4, I get a 0 here. So I had no allocation here. 0 plus 4, I get a 4 here. So 7 minus 4, I get a 3 here. 5 plus 4, I get a 9 here. So it is 3490. 3, 4, 9 and a 0. This is the modification that we have done. So compute the TTC and check whether the cost has improved. So the TTC is 11 into 13, 6 into 17, plus 3 into 14, plus 4 into 23, plus 10 into 27, plus 9 into 18, which will lead to 811. Earlier it was 896. So there is an improvement in the cost. So this is an improved solution, but we don't know whether it is optimal or not. So we need to go about checking whether it is optimal or not by once again performing stepping stone. So how many allocations we have? 1, 2, 3, 4, 5, 6. Still a non-degeneracy case. Very good. So go about performing stepping stone starting from O1D1. So O1D1 is an occupied cell. Consider that as reference, form a closed loop. O1D1 to O1D4, then to O2D4, then to O2D1, back to the original position. Alternating signs, plus, minus, plus, minus. The closed loop was O1D1, O1D4, O2D4, O2D1. So the net cost change will be plus 21, minus 13, plus 23, minus 17, which will evaluate to plus 14. So go to the next unoccupied cell, O1D2. So the loop that I get is O1D2 to O1D4 to O2D4 to O2D3 to O3D3 to O3D2 and back to the original position. So I get a hexagon. So put alternating signs, plus, minus, plus, minus, plus, minus. So the closed loop is O1D2, O1D4, O2D4, O2D3, O3D3, O3D2. So the net cost change will be plus 16, minus 13, plus 23, minus 14. Plus 14, minus 18, plus 18 and a minus 27. When I evaluate it, so I get a plus 3, so which is an increase in cost. Therefore, we will have to go to the next unoccupied cell, O1D3. So for O1D3, when I form the loop, it is O1D3, O1D4, O2D4, O2D3. Put alternating signs, plus, minus, plus, minus. So the net cost change will be plus 25, minus 13, plus 23, minus 14. When I evaluate it, I get a plus 21, which is also an increase in cost. So go to the next one, O2D2. So when I consider O2D2, the loop that I get is O2D2, O2D3, O3D3, O3D2. Okay, this is the loop that I get. Put alternating signs, plus, minus, plus, minus. The net cost change will be plus 18, minus 14, plus 18, minus 27. So which will give me a net cost change of minus 5. So whatever solution I had got was not an optimal solution. There is still a chance to improve the solution. So this is a decrease in cost. So go to the next unoccupied cell, O3D1. So with O3D1, when I form a loop, it is O3D1, O2D1, O2D3, O3D3. So this is the loop. So for this, put alternating signs, plus, minus, plus, and a minus. So the net cost change will be plus 32, minus 17, plus 14, minus 18. Sorry, here there is a typing mistake. It has been typed as 28, but still the value is positive only. Plus 12. So it is an increase in cost. Consider the next unoccupied cell, O3D4. So with O3D4, when I form a loop, I get O3D4, O3D3, O2D3, O2D2, O2D4. So put alternating signs, plus, minus, plus, minus. So the net cost change that I get is plus 41, minus 18, plus 14, minus 23. So which will evaluate to plus 14, which is also an increase in cost. So in this entire table, there is only one possible decrease. So that is the most negative decrease. Consider that particular loop, O2D2, O2D3, O3D3, O3D2. Okay, in this loop, wherever I have minus sign, identify those allocations. I have 10 and I have a 3. So out of this, 3 is minimum, 3 can be moved. So 3 minus 3, this becomes a 0. 0 plus 3, this becomes a 3. 10 minus 3 becomes a 7. And 9 plus 3 becomes a 12. So I get 30712 as a modified. 30712 as a modified. Check the possibility here. Sorry, TTC. It is 11 into 13 plus 6 into 17 plus 3 into 18 plus 4 into 23 plus 7 into 27 plus 12 into 18. So I get a 796, which is an improvisation when compared to the previous solution. So this is an improved solution, but may not be optimal. So we need to check it out. So here O1 D1. So when you form a loop, I get the net cost change as plus 21 minus 13 plus 23 minus 17 plus 14. So which is an increase. Next O1 D2. So I get the loop. So the net cost change will be plus 16 minus 13 plus 23 minus 18. So which will be a plus 8, which is also an increase. So O1 D3 is the next reference. So here I will just show you the loop, because this is a different type of loop that you have not encountered till now. So the point of reference is O1 D3. From here I move to O1 D4. From O1 D4 I move to O2 D4. From O2 D4 I move to O2 D2. From O2 D2 O3 D2. From O3 D2 to O3 D3 and back to the original location O1 D3. Right? So this is a different type of loop that you have not encountered till now. Okay? So the loop is O1 D3, O1 D4, O2 D4, O2 D2, O3 D2, O3 D3. Okay? Now for this, put the alternating signs: plus, minus, plus, minus, plus, minus. Calculate the net cost change: plus 25, minus 13, plus 23, minus 18, plus 27, minus 18. So this will evaluate to plus 26. Go to the next unoccupied cell, O2 D3. The loop that I get is O2 D3, O3 D3, O3 D2, O2 D2. So the net cost change will be plus 14, minus 18, plus 27, minus 18. So which will evaluate to plus 5. So go to the next unoccupied cell, O3 D1. The loop that I get is O3 D1, O2 D1, O2 D2, O3 D2. Right? So the net cost change will be plus 32, minus 17, plus 18, minus 27. So which will evaluate to plus 6, which is also causing an increase. Go to the next unoccupied cell, O3 D4. So the loop is O3 D4, O3 D2, O2 D2, O2 D4. So the net cost change is plus 41, minus 27, plus 18, and minus 23. So which will also evaluate to plus 9, which is also an increase. See, I have got all net cost change as increase. So whatever solution I had got is an optimal solution. All are shaded in red. Therefore, the solution that I have got here is the optimal solution. So once again, recalculate the TTC for the optimal solution. It is 11 into 13 plus 6 into 17 plus 3 into 18 plus 4 into 23 plus 7 into 27 plus 12 into 18. So which will be rupees 796. We started in the IBFS with 922. Now I have arrived at 796. So this is an optimal solution or the best solution for the problem. Hope you have understood the stepping stone method. This is a bit lengthy, but it is easier when compared to Modi method. So hope you people have understood. Any doubts you can post on the comment section. Thank you. Thank you for your patient listening. This completes transportation problem and also your unit 2. Unit 2 gets over here. So in the next post, I'll be sending all the question paper problems that are related to this chapter so that you can write it as an assignment and you can keep it ready for submission when the college reopens. Till then, have a nice time. Enjoy. Thank you.